Hello, this is Reza again. In this portion of my video, I'm going to teach you some test-taking skills that will come in handy on any multiple choice math test that you will take ever. The first of these two test-taking skills is called back-solving. Back-solving usually works on problems whose answers are numerical, like these guys. The idea here is, instead of ignoring the answers and trying to solve the problem to see which answer matches yours, we will actually use the answers that the problem provides to figure out which one works. Sometimes this is faster than doing the algebra for the problem, but more importantly, sometimes this will actually enable you to solve a problem you may not know how to solve. So this method will definitely gain you points on the test, and it's worth learning and practicing. So the first problem on my sheet here reads, an office has 27 employees. If there are 7 more women than men in the office, how many employees are women? Usually you would solve an algebraic equation to solve this problem, but let's see how this one works with back solving. The first thing I need to do is to pay attention to what they're asking for. They're asking for how many employees are women. That means all these numbers down here are the number of possible employees that are women at this office. So one way I can solve this problem is I will make a chart, women and men, and then I'm going to try this middle answer here, the number 14, to see if it's the correct answer to this question, how many employees are women. So I'll put it under the women's column right here. Now, then the next step is I read through the problem again. An office has 27 employees. Well, I can now figure that there must be 13 men in this office. There are 7 more women than men in the office. Well, that obviously didn't happen, so clearly this is not the correct answer to the problem. But since I only ended up with 1 extra woman in this office, then I can probably tell that the correct number of women must be bigger than 14. That's why I started in the middle here, because now I know I don't need to try these 2 numbers over here. So I'm going to try the 17 over here for the number of women next. If I read the question again, an office has 27 employees, that tells me I got 10 men in there, and now I do have exactly 7 more women than men in the office. Here is the correct answer. I didn't write any X's or Y's, all I did was arithmetic in this chart. Okay, let's look at the next problem. It says, on Tuesday, a store owner received a shipment of pens. On Wednesday, she sold half of them. On Thursday, after selling 2 more pens, she had exactly 2/5 of the pens left. How many pens were in the shipment? Okay, well, let's try to solve this by back solving. Again, the first thing we do is we pay attention to what they're asking for, because these numbers are the numbers that are the answers to this question. So therefore, these numbers are all the number of pens that came in on Tuesday. So I'm going to make another chart. Tuesday, Wednesday, and Thursday. Now, the next step is, of course, I take the middle answer like I did up here, and that answer is the number of pens that came in on Tuesday, so I put it over here. Then I read from the start. On Tuesday, a store owner received a shipment of pens. On Wednesday, she sold half of them. Well, that means she's got 15 pens left on Wednesday. On Thursday, she sold 2 more pens, so that means she's got 13 pens left now. Then it says she had exactly 2/5 of the pens left. Well, if I do 2/5 of 30, I get a 12, not a 13. So this number came out a little bit too big. Therefore, I'm going to cross this out, and now I'm going to try a smaller number than the one that I started with, 20. Then I read the question again. On Wednesday, she sold half of them. On Thursday, she sold 2 more. Now, 2/5 of 20 is exactly 8, so this answer worked. All right. The next question reads, what is the largest integer n such that 112 divided by 2 to the n is an integer? Well, if I start here in the middle with the number 3, and I put it in here and it works, then I wouldn't be able to circle this answer because it's asking you for the largest integer that does the job. So then the smarter thing to do in a problem like this is to start here at the bottom with the biggest number that we have on the list. So I plug this 5 in there and I say 112 divided by 2 to the 5th. Now, if I compute this on my calculator, I'll see that the calculator says this is 3.5. So this is not an integer as the problem is asking for. So I'm going to cross this out. Next, I'm going to try the 4. 112 divided by 2 to the 4th. Again, a check with my calculator shows that this one gives me a 7. And that is an integer. Therefore, this is the correct answer I'm looking for. That's the largest one of these values that makes this fraction into an integer. So, at this point, I'd like you to copy down a flashcard. So, take an index card. On the clue side, write down back solving. This stands for strategy. Then, on the other side, write down 1. Usually works on problems with numerical answers. 2. Try the answers into the problem to see which one works. 3. Usually C is the best first choice, like these two problems. Unless the problem is asking for the greatest or least values, like this one right here. So in this case, we started with the biggest number. Make a chart if you can. Chart was helpful in these two problems, but we didn't really need one for this one. Okay? If you need more time to copy this, just stop the video here and copy the rest. Okay. Next question, number 4, says Peter had twice as many pens as Delia, who had the same number of pens as Zach. If Peter gives 5 pens to Zach, Delia will have 3 times as many pens as Peter. How many pens did Delia have? Alright, so I got 3 people here. Peter, Delia, and Zach. First, if I'm going to back solve this, I pay attention to what they're asking for. How many pens did Delia have? Well, let's choose the middle answer here as the answer to this question. Therefore, this number 3 goes under Delia. So now if I read from the start, Peter had twice as many pens as Delia. That means Peter had 6. Who had the same number of pens as Zach? That means Delia had the same number of pens as Zach. So Zach must have had 3. Alright. Peter gives 5 pens to Zach. So now Peter has only 1. Zach has 8. And Delia didn't change. Then Delia will have 3 times as many pens as Peter. There we go. She does have 3 times as many pens as Peter. Therefore, this answer worked. That's my correct answer. Okay, let's flip the page to the next page right here. Okay. The next problem reads, the price of a jacket is reduced by 20%. 1 week later, the new price is reduced by 15%. If the final price of the jacket is $170, what was the original price of the jacket? Alright, so let's see if the original price was $200. Then, after the first discount, reduce this by 20%. If you do 0.2 times 200 on your calculator, it gives you 40. So when you reduce 200 by 40, you get 160. So after the first reduction, the price of a $200 jacket goes down to 160. And that's already lower than our target price. So this number is obviously too small. I don't want to try these. Next number I'm going to try is 250. Now, after the first reduction, I take 20% of 250, which is on your calculator 0.2 times 250 is 50. So when I reduce that by $50, I get 200. Now, then after that, a week later, the new price is reduced by 15%. So if you figured out 15% of 200 on your calculator, you do 0.15 times 200, it gives you 30. So when you reduce this by 30, you get 170. That's the second discount. And that is exactly the target number that we're looking for, $170. So this answer worked. There you go. We didn't do any algebra to solve this problem. Next question says Cindy has 4 more hats than Aaron and half as many hats as Michael. If the 3 together have 24 hats, how many hats does Michael have? All right, let's try to back solve this one. First of all, it's asking for how many hats does Michael have? So I have Michael, I have Cindy, and I have Aaron. Let's try the middle answer here. That would be the number of hats that Michael has. So I put it down over here. Cindy has 4 more hats than Aaron and half as many as Michael. That means Cindy has half as many as Michael. So Cindy's got 6. And now, since she has 4 more hats than Aaron, that means Aaron must have 2 hats. Now, the total number of these hats adds up to 18 and 2, 20. But it says they all have 24 hats. So clearly, this number was too small. I'm going to try 14 now. Cindy has half as many of those. Aaron has 4 less. Now when I add these up, I get 24, and that's what I wanted. There's the correct answer. Much, much faster than doing this by algebra. Make sure you understand that you can't do this every single time you see a problem with numerical answers. Sometimes you can, but not always. So what you should do in solving a problem is do the fastest possible way to solve a problem. But this method sometimes saves you time, and sometimes it actually gets you the answer to a question you may not know how to solve. So it's important to learn it and practice it and get good at it. All right. Next thing we're going to talk about today is the topic of plugging in. Here we go. Okay. Plugging in is another method of taking advantage of the multiple choice answer choices for this test. This method usually works on problems whose answers have variables in them or percent signs in them or even fractions in them. If you ever see a problem with these 3 words in it, in terms of, you can be sure that this method will solve it. The idea here is, instead of doing the problem using algebra, we will put our own numbers in for the variables that are supplied, and then we'll do the problem using arithmetic. Sometimes this is faster than doing the algebra. Sometimes this also gives you the ability to solve a problem you may not know how to solve. So just like the method before, it's important to learn this, practice it, and get good at it, because it will gain you points on the test. The first problem reads, Jeff was K years of age 2 years ago. In terms of K, how old would Jeff be 2 years from now? This is a very simple problem. We'd never use this method to solve it, but just so we can learn how this method works, well, we've got the 3 magic words in the problem, as well as variables in the answers. So one thing I can do to solve this problem is pick a value for K. Let's say I choose 4. I'm going to write it on top of K over here. When I choose my own numbers to solve a problem, I have to remember to disregard this phrase in terms of blank. Then I read the question, Jeff was 4 years of age 2 years ago. How old will Jeff be 2 years from now? Well, if Jeff was 4 2 years ago, that means he's 6 now, and 2 years from now he's going to be 8. So this is the numerical answer to my question based on my numbers. I'm going to call it my target number, write it down near the answers and circle it. Next thing I do is I take the value of K that I chose, put it in all the answers looking for an 8. 4 plus 4 is 8, that works. 4 plus 2 is 6, no good. 2 times 4 is another 8, and 4 and 2, no good. Notice I didn't stop when I found an answer that worked, as opposed to the previous method when we stopped when an answer worked. Here, because I can come up with more than one possible answer choice that matches my number, I got to test all of them every single time. You go from A to E and test every one. If this ever happens, what you do is you just change your numbers that you've chosen, read the question again, come up with a new target number based on your new number, and then just test the two things that came up okay last time. So I put in 5 plus 4, it still matches right there. 2 times 5 is 10, no longer matches. Therefore, this is the correct answer choice for this problem. The next question reads, if n is equal to m times p, then which of the following is equal to m divided by p? Okay, so I'm going to pick some numbers for n, m, and p here. Let's say I pick m is 3, p is 2, and that would make in n 6 because it has to be equal to 3 times 2. So don't forget, the numbers that you choose have to actually work in the premise of the problem. So 6 is equal to 3 times 2. Which of the following is equal to m divided by p? Now m divided by p in my problem is 3/2. So therefore, this is my target number. Now I test the answers. N over mp is 6 over 6. That's a 1. Nm over p is 18 over 2. That's 9. N over p is 6 over 2. That's a 3. N over p squared is 6 over 4, which is actually the same as 3 over 2. So this matches. N over mp squared is 6 divided by 3 times 4, which is 6 over 12. That does not match. This is the only matching answer. There is my answer. Next question says, if a is an odd integer, b is an even integer, which of the following must be odd? All right, so I'm going to pick a to be 3, b to be 4. Odd and even. So I'm looking for an odd number in the answer choices. 2a is 6, plus b is 4, that's 10, that is even. A is 3 plus 2b is 8, that's 11. That one works. A times b is 12, that is no good. A squared b is 9 times 4, 36, that's no good. AB squared is 3 times 16, which is 48. That also doesn't work. Here's the correct answer. Alright, now you need to copy another flashcard. This one says plugging in strategy. So on the other side, it reads this. Usually works on problems with variables, percents, or fractions in the answers. 2. Always works on problems with in terms of in them. 3. Choose your own numbers, avoid 0, 1, or 2. 4. Change your numbers if computations get ugly. 5. Find a numerical solution to the problem. This is your target number. 6. Try all answer choices. Now, again, if you need more time, just stop the video to copy this stuff. You may wonder why it says avoid 0, 1, or 2 over here. Over the years, I found that these 3 numbers lead you to multiple answer choices more often than others. So I advise against them. But look, we chose a 2 in this problem and nothing bad happened. So it's not all the time that it gives you trouble. All right. The next question says, the sum of 4 consecutive integers is s. In terms of s, what is the largest of the above integers? So again, I've got the 3 magic words, variables in the answers. Let's pick some numbers for this. So if I want to pick a value for s, since it says that's the sum of 4 consecutive integers, maybe I should pick 4 consecutive integers first. So let's go with 3, 4, 5, and 6. If I add these things together, 3 plus 4 plus 5 plus 6, I get 18. So then that means the value of s, the sum of these guys, is 18. Then I get rid of this phrase in terms of s, and I read what is the largest of the above integers? By the above integers, they mean these 4 consecutive integers. The largest of them is this number 6. That is my target number. So now, I go into the answers, put the 18 in for S to see which one gives me a 6. This is 18 minus 12, 6 divided by 4, that's 1.5, no good. 18 minus 6 is 12 divided by 4, that's 3, no good. Feel free to check these with your calculator. If I'm going too fast, stop the video and check these with your calculator. 18 plus 6 is 24. 24 divided by 4, it does equal a 6. 18 plus 12 is 30. 30 divided by 4 is too high. And this one is also too high. So here we are. There is the correct answer. Much quicker than doing this problem with algebraic methods. Okay, let's flip the page over to the next problem. Problem 5. Okay. Problem 5 reads, from 1985 to 1990, the population of a village increased by 20%. From 90 to 95, the population of the village increased by 30%. What was the percent increase in the population of the village from 85 to 95? Notice that even though I have percent signs in the answers, which is one indicator that you can plug in to solve the problem, I don't have any variables here. So the question is, what do I plug in a number for? Well, the thing that you need to plug a number for is the population of the village to start with. Since I'm dealing with percentages here, the best number to choose is 100. Now, I start with, in 1985, with 100 people in this village. Then, it says the population increased by 20% from 85 to 90. So then that means in 1990, I had 120 people in the village. That's 20% increase. Then, it says from 90 to 95, the population of the village increased by 30%. So, then, in 1995, I need to find 30% of 120, which I can do by pressing 0.3 times 120 on my calculator. If I do that, my calculator tells me that 30% of this number is 36. If I add that to the 1990 population, I get 156. Then it says, what was the percent increase in the population from 85 to 95? So what's the percentage increase from 100 to 156? Looking at the answers, it should be obvious that this is the percentage increase from 100 to 156. It's 56%. So generally speaking, if you have percent signs in the answer choices, you can just start with 100 and work your way through the problem. Life gets a lot easier. Okay. The next question reads, at an amusement park, each employee speaks exactly one foreign language, in addition to English. 3/5 of the employees speak Spanish, and 1/4 of the remaining employees speak Portuguese. If all the other employees speak French, what percent of the employees speak French? All right. So, just like the previous problem, I'm dealing with percent signs in the answers. So, let's pick 100 and work through the problem. The 100 would be the number of employees at this park. So, I'll put 100 down over here. Now, since we have branches of different types of language speakers, I'm going to make a tree to keep track of. 3/5 of the employees speak Spanish. Now, if you multiply 3/5 times 100 on your calculator, it says 60. That means 60 people speak Spanish. That's S. Therefore, 40 people are non-Spanish speakers. Then it says 1/4 of the remaining employees speak Portuguese. That means 1/4 of these guys. So that means 10 people speak Portuguese, and then 30 people are non-Portuguese speakers. If all the other employees speak French, that would be these folks right here. What percent of the employees speak French? It's easy to see. The answer is 30%. Next problem reads 7. The ratio of A to B is 1/2, and the ratio of C to B is 1/3. Find what is the average of A and B in terms of A and C in terms of B. Well, I've got the three magic words in the problem again, variables in the answers. So let's plug in. Now, let's say I pick 5 for A and then 10 for B. So now the ratio is 1 to 2. Now, C to B is 1/3, B is already 10. C gets ugly though, because it has to be 1/3 of 10. So then these numbers are no good. I need to come up with new numbers. B has to be divisible by 2 and 3. So how about I pick 12 for B? I put that in first. Now, A to 12 is 1 to 2, that means A is 6. C to 12 is 1 to 3, which means C has to be 4. Now all the numbers worked. So as you can see, that's what that flashcard said. Change your numbers if computations get ugly. So we change these numbers to these new ones. Much, much more easy to work with. Now, I'm going to get rid of this in terms of B phrase and then read what's the average of A and C. Well, the average of 6 and 4 is 5. 6 plus 4 divided by 2 is 5. That's my target number. Now I go put the B into the answers looking for a 5. 12 divided by 6 is a 2. 12 divided by 4 is a 3. 5 times 12 is 60. 60 divided by 12 actually matches 5. 12 divided by 2 is a 6. And 60 divided by 6 is a 10. Therefore, there's the correct answer choice. Much, much faster than algebra. 8. Omar spilled 2/5 of his mints on the way back from the movie theater. Doreen, who was sitting next to him, ate 1/3 of what was left. Doreen then gave the bag to Anne and Jill, who split what was left equally between them. What fractional part of Omar's mints did Anne eat? Okay, so let's pick a number for the number of mints that Omar had to start with. How about we go with 20? Okay, so I'm going to make another tree like this. He spilled 2/5 of his mints. 2/5 of 20 is 8. So these were spilled. That means 12 remained. Doreen, who was sitting next to him, ate 1/3 of what was left. So now 1/3 of 12 is 4. That goes for Doreen. That means 8 mints are left. Doreen then gave the bag to Anne and Jill, who split what was left equally between them. So that means 4 of them Anne eats, 4 of them Jill eats. What fractional part of Omar's mints did Anne eat? Well, the answer is 4 out of 20, which simplifies to 1/5. Very, very quick and easy. Okay, number 9. If A equals B plus 0.5, B equals 2C plus 0.5, C equals 3D plus 0.5, which of the following is an expression for D in terms of A? Okay, now, if I pick a number for A here, then let's say I pick 5. Then B becomes 4.5. Then C becomes, this is 4.5, so 2C is 4. C becomes 2. And then if C is 2, then 3D becomes 1.5. And D gets ugly. So, you know what? I'm going to just start with D and work my way this way, rather than working my way this way. That would probably be easier for us. Let's say D is 3. Then C would be 9.5. Put 9.5 in here. I get 2 times 9.5 is 19 plus 0.5. B is 19.5. And then I put it in here, and A becomes 20. All right, much better set of numbers than what we started out with. So sometimes it matters which variable you choose first, because it makes your life easier in choosing the other variables. Now, it's asking you which of the following is an expression for D in terms of A. Well, first of all, I'm going to get rid of in terms of A, because I'm plugging in. And then they're basically asking for the value of D, which means that this is my target number, 3. So now, I put the value of a in the answers to see which one is 3. So this one is 20 minus 2 is 18 divided by 6. That does work right there. This one is 40 minus 3, which is 37 divided by 6. That doesn't work. This is 37 divided by 12. That's also not a 3. This is 60 minus 2, which is 58 divided by 18. That doesn't work. And that's 80 minus 3, 77 divided by 24. That is also not equal to 3. Here is the correct answer choice. All right, wonderful. So this is the end of this lesson. Now, you have some homework to do after this lesson is over. So pay attention to the email that you received about this homework and do the homework according to the instructions in the email. Thank you for watching.